We've got Harsha and Anand, who are going to introduce us to their tool, Cobra. The title of their talk, fittingly, is Cloud Offensive Breach and Risk Assessment, also known as Cobra. Please give a warm welcome to Harsha and Anand.
Thank you everyone for joining us today, and we are going to present our open source project called Cobra, Cloud Offensive Breach and Risk Assessment. And with that, before we introduce, so my name is Anand Tiwari, and I'm currently working with Palo Alto Networks as a product manager, and with me Harsha is a researcher and product manager at Palo Alto. So we both have a security research background, and we started recently switched our career from researcher to product managers. So here, before we talk about our open source project, I just wanted to highlight a couple of challenges and gaps with running multi-cloud attack simulations. And after running all the research and what we have seen in the past, we identified out there are multiple tools available to simulate the cloud attacks, and those are the first we identified, like those are single pointed specific threat and vulnerability use cases simulation, and they are lacking simulating multi-dimensional attack scenarios in the cloud, and also it's difficulty to evaluating new security vendors for cloud native advanced use cases. So like nowadays attacks are so much advanced in the cloud, and to like evaluate your controls and tools which you use for defending cloud, you need to know the advanced attack, and you need to run those advanced attack in your environment where your controls are in place. So to using those environment and running, it's very hard, right? So also it's very hard to manage and build multi-stage cloud environment labs to test your control, right? That is takes a lot of time to go and figure out the attack paths, and then write the labs, and then run attack, and then see the controls are working or not, right? So that is it's very hard to do with the simulated realistic attack path scenarios. So with that, we come up with the tool called Cobra, Cloud Offensive Breach Risk Assessment tool, and it's basically provision the vulnerable environment and then attack on that vulnerable environment. So basically it's simulate the multi-dimensional attack in the cloud, and that you know the advanced attack paths comes in the cloud, and people are connecting bits, and then they are exploiting the cloud environment. So Cobra does it's build the entire vulnerable environment, and then it's also start attacking whatever the environment has built, right? And it's the Cobra tool used for validating your controls in place. Let's suppose you are implementing control to prevent the cloud attacks in your staging and production environment. So you can go and validate whether all those are in place and working as expected, and also you're going to be confident by running this tool to understand all those can be prevented and detected all the attacks. So with that, I'm going to hand over Harsha to more talk about how the environment looks like and other things.
Hey guys, this is Harsha, and before jumping into the demo, I'll just drive all of you through the architecture of Cobra. So here on the left side, you can see Cobra's control plane. This is where you run your tool. This is all your workstations. And then here you have Pulumi. Basically, this is the infra layer. We use Pulumi to create all the infrastructure needed. This is just like Terraform, but Pulumi supports various languages like Python, Rust, Go, whichever. So we wanted to make it developer friendly. So whichever language you're comfortable in, you can write infra code in that language. So each infra component is like a function. Think of a Terraform module to compare. So with infra, this layer, we basically create all the infrastructure needed here. Here on the right side, you can see example scenario. This is our scenario 1. So this is your attacker machine. Pulumi spins up an attacker machine, and then we spin up a vulnerable EC2 with a vulnerable container, and then this EC2 has got a role attached. This is where you have your IMDS V1 or V2 endpoint, and through this, attacker is behind Tor, and he basically exploits this vulnerable container, basically a layer 7 payload, and then gets a shell, then gets all the credentials, exfiltrates it, and he rolls out all the anomalous compute he needs, maybe for a backdoor or even for, think of a crypto miner, right? A typical end-to-end simulated attack scenario. So this is how the architecture is going to look like. So now let's switch over to demo. So to basically run simulation, you just have to say Cobra, which cloud, launch, and simulation. So these are the current scenarios we support. We have started adding Azure and other clouds as well. So I'll just drive you through all these scenarios, and then we can run one of it. So first one I will just explain in the architecture, and second one is REST API, and then this Lambda backed. This API gateway and Lambda has a command injection, and then we do a credential exfiltration from the Lambda. Basically, that is a role attached to the Lambda, the default role, the service role of Lambda. And then we basically escalate our privileges from the Lambda role. And you use this exfiltrated credential from the attacker machine, and then create a backdoor. The backdoor could be a user, it could be a role, it could be a function, it could be something like an SQSQ, whichever is your choice. And the third one is there's a vulnerable pod which is living in a GK cluster. So we basically try to get into the pod, again exploiting a layer 7 vulnerability. Once you get into the pod, you access the pod's default secret service account, and then you escalate your privileges because that service account is slightly overprivileged. And then you escalate your privileges, try to take over the cluster and possibly the whole GCP project. So this is one more end-to-end simulated attack. The fourth one goes like this. Let's say there's an EC2, you just stop the EC2, change the user data script with just single permission called modify instance metadata attribute. Once you change the user script, our rogue script will run there, exfiltrate IMDS credential. This is V2 credential. Usually we see V1 exfiltration, but in this case we can demonstrate a V2, exfiltrating a V2 credential, and then we send this credential to a remote server where we host a HTTP or Python server, and you just exfiltrate that credential and send it out and leave from the infrastructure. And the fifth one is like, this is a typical ransomware attack we see in the wild, where an instance is taken over or a Lambda is taken over, and that entity has got access to data in S3, Dynamo, various other forms of data. Then we use external KMS key, our attacker KMS key, to encrypt this whole bucket and leave the infra, right? So these are the typical scenarios right now we have, and for this demo purpose, I'm running scenario 2. So once I just enter, it will start creating all the infra needed. So here you can see this is trying to create all the infra. So Pulumi creates infra in a stack. In the stack you have role, REST API, stage, all the permission roles needed, and it will throw some outputs. These outputs are just like Terraform output or CloudFormation output. So these outputs we use in the report as well. So Pulumi clearly says how much time it is going to take, to create each component of the infrastructure. So once it creates all the infra, we will start the attack automatically. So now it's created infrastructure, and these are the outputs, and it says exploiting the application on the API gateway, and it detected an OS injection, and the attempt to exfiltrate the credential, we have exfiltrated it, and now it will do an STS call and show what credential is exfiltrated. So this is the arm of the temporary role of Lambda which we exfiltrated. And now once it exfiltrates this, it will load this credential in the attacker machine, and it starts to see what are all the possible ways that we can escalate this privileges, possible all the escalate. So what it will try to do is, in this case, there's a role and there's a policy called attach policy. That is the overprivileged policy in this role. So this will be using that policy to attach a new policy, which is maybe slightly overprivileged, like admin or power user. So once we attach that policy to this role becomes slightly powerful than it is usually, right? So then we refresh our credential in the attacker machine just by doing an STS call and seeing, whether the credential is refreshed or not. Once the credential is refreshed, the attacker will continue doing his job. In this case, it is rolling out a backdoor role or a backdoor user or a backdoor function. Yeah, we have 3 more seconds left until it completes it. Yeah, so it is creating a backdoor user here, and the user will be called DevOps. And this is something you can configure, because let's say you don't want your SOC people to detect that you have created something like this. It's configurable. And once the attack is simulated, Cobra is going to generate a report for you, and this is how the report is going to look like. The report has multiple sections to it. The first section basically explains what is the scenario all about in brief, and the second section is a breakdown of what all we have been doing in the scenario till now. You can see the application is being exploited, and the Lambda role credential is discovered and exfiltrated, and we discovered that there's a privileged possibility, and then we have exfiltrated it, and we attach a privileged policy to this role, and we started provisioning a backdoor user in this case, but you can provision a role as well to maintain persistence later. So if you're maintaining a backdoor role, you'll have to whitelist your own principal from your account ID, so that you can later assume this role and come in back at a later endpoint. And you have an attack path graph generated. This is all about how the attack looks like. So you see the attacker here, there's a gateway, there is Lambda, the role. We have performed OS injection at this point, exfiltrated the credential from here, loaded it in the attacker machine, and then started using this credential to provision a backdoor role. This is the 5th step. So you can see the attack sequence here in the architecture diagram, and it also pulls out certain resource metadata, so that you can pinpoint, you can go back and see that which cloud resources are being attacked, what all have we created till now, right? Think of using this tool to evaluate some of your CNAP vendors or something, where you say them, hey, I have like list of attacks, can you detect and prevent, for me? So that way you can basically see if there's a value add of a product, or CSPM, CNAP, whatever it is, right? So then it will give you a list of controls to evaluate post attack. So in this case, it's like checking your API gateway has a auth-in or auth-z, and having a WAF or not, to basically prevent the L7 attacks here. And then it will see there's a Lambda defender layer which could prevent the possible injection, or So, and then if you have doing the role exfil, you can monitor in CloudTrail and see if there's anything anomalous that somebody's trying to do STS calls from outside, which is not usual. And then if there's any SCPs in place, because we were trying to attach a privileged policy to the newly created, to the default Lambda role, in that case the SCP should block it if you have SCPs configured, and basically detecting if there's any new user role or group creations which is quite anomalous. Through a Lambda role, nobody does create user role, user entities usually. So this is how the report looks like. This is it for the demo. I'll hand it over to Anand.
Okay, thank you, Harsha. Now let's talk about how to contribute to this project, right? So basically, you can get this tool access because we have hosted on GitHub, and it's open source. So you can go and raise the issues. If you find any issue, or if you have any feedback, or you wanted to add some more scenarios, so you can request it through new issues. Right now we don't have any page or anything form, but you can start using the issues, because we are very, very active on this GitHub account. And we also started writing the template based contribution. So already we are working on to have the template, so that you can easily contribute with the more scenarios. So now if you want to do more contribution, give us more feedback, and we are looking forward to make this tool more useful for community, and you can use for validating your controls by running this simulated attack. So with that, we are open for QA. So if you have any question, anything related to Cobra, just reach out to us. We are pretty much responsive. Yeah. Okay. So we are around there for 10-15 minutes. If you want, you can directly reach out to us. Yeah. Thank you for joining us.